on the type or types of intermolecular forces predict the substance in each pair that has the higher boiling point. Well, first we need to know what are intermolecular forces, how to recognize them, and how they're connected to the boiling point. Intermolecular forces are forces of attraction between molecules. They can be basically divided into 4 categories. I have listed these categories in order of strength from the strongest to the weakest, and I also wrote a little way to recognize them. The first intermolecular force is ion-ion, which is the strongest force. It is the force that is between ions in ionic compounds, and in order to recognize it, you will just have to look at the formula, and you will have to see, does it have a metal plus a non-metal, a metal, and polyatomic ion, or it could also be 2 polyatomic ions and a polyatomic ion and non-metal, but those are much more rare cases, so usually you will just see either a metal plus a non-metal or a metal and polyatomic ion, such as NaCl, metal non-metal, or metal and polyatomic ion like NaNO3, sodium nitrate. The second category that is fairly strong is hydrogen bonding. Even though it has the word bonding in it, it's still an intermolecular force. It is not a bond. It's not a covalent bond. In order to recognize it, you will just have to look for OH, FH, or NH. If your molecule has either OH, FH, or NH, then the molecule is capable of hydrogen bonding and contains that force. The next is dipole-dipole force, and dipole-dipole force is present in polar molecules. To recognize whether molecules polar or non-polar is a little bit difficult, and it will be another one of my videos that you can look at. And the last force is dispersion force. Dispersion force is present in all compounds, so everyone has it, but only nonpolar molecules have it as the only force. So for nonpolar molecules, they only have dispersion. Other molecules will have dispersion along with other forces. For dispersion forces, we should also know that the stronger the molar mass of a molecule, the higher the dispersion force. So if you're looking between 2 molecules that have the same forces, dispersion forces, we will have to look at their molar mass to predict who has stronger intermolecular forces. The next thing we will learn is how are intermolecular forces connected to the boiling point. If you think about it, intermolecular forces basically are forces of attraction between molecules. The stronger the attraction, the harder it is to push the molecules apart from one another, to separate them. And boiling point is the temperature needed for a liquid to become gas. So we need to separate liquid molecules. We need to separate molecules in their liquid phase to become gaseous. We need to create a higher distance between them. So we need to overcome the intermolecular forces. Therefore, the stronger the intermolecular force, the harder it will be to overcome it, to separate the molecules, and the higher will the boiling point be. Now that we have all of this, we can go ahead and look at our examples. A is propane versus butane. If we look at the 2 molecules, we can see that we have 3 carbons here, 4 carbons here. Also, you should know that if I only have carbons and hydrogens, the molecule is always nonpolar. If the molecule only has carbon and hydrogens, it is nonpolar. Therefore, both of these molecules have dispersion forces. Let's write it. Okay, now they both have dispersion forces, so in order to see which one has higher intermolecular force, we need to look at its molar mass. The molecule to the right has 4 carbons, to the left has only 3 carbons. Therefore, n-butane has a higher molar mass, it has more carbons and hydrogen, it has stronger intermolecular forces, and therefore it will have a higher boiling point. Let's go ahead and look at B. For B, we have diethyl ether with this formula and butanol with this formula. We want to notice right away that butanol has an OH group, and OH group, we said, is present with molecules that are capable of hydrogen bonding. So this molecule is capable of hydrogen bonding. It has hydrogen bonding as an intermolecular force. It also has dispersion. Let me write dispersion just to list all forces. For the molecule on the left, it's mostly carbons and hydrogens. It also has an oxygen, but the molecule is symmetrical. And again, we will talk a little bit more about polar versus nonpolar molecules in a different video. But because it's symmetrical and it does not have OH bond, therefore it is nonpolar, and therefore it has dispersion forces only. Hydrogen bonding is much stronger than the dispersion forces, therefore the molecule on the right will have a higher boiling point. Now let's go ahead and go to C. We have SO2 versus SO3. I already put the structures together. So what we need to know for these molecules, definitely they do not have ion because we don't have any metals or polyatomic ions. No hydrogen bonding, we don't have OH, FH, and H. The only two things they could possibly have are dipole-dipole dispersion, so we will look at it. SO2 is a molecule that has the shape bent. It has a bent shape, and therefore its charges are not equally distributed, and that's what makes it polar. And if it's polar, it has a dipole-dipole force. So we will write dipole. Like the rest of the molecules, it will also have dispersion, so we will add dispersion also. SO3 has trigonal planar shape. It is absolutely symmetrical. Its charge is distributed equally, and therefore this molecule is nonpolar. Nonpolar molecules have only dispersion forces. Dispersion. If we look at this, we could think that possibly SO2 would be stronger. However, this is an exception. Once in a while, dispersion forces can overcome other forces and be stronger. In this case, because SO2 has a higher molar mass, it will have a stronger dispersion force, and that will actually be able to overcome the dipole-dipole force, and therefore SO3 will have the highest boiling point. This is an exception, so I would think that on the test or on a quiz, your teacher would have to say SO3 has a higher boiling point. Why is it? Why, or how can you explain that? So you would say, well, it has higher molar mass because it has higher molar mass, it has stronger dispersion forces. However, just looking at it, it would be hard to recognize which one is stronger, so we will just memorize it as an exception. For choice D, we have Cl2CO and H2CO. Cl2CO looks like this, and H2CO looks like this. You can see that these are really similar looking molecules. Now, again, because my central atom is connected to different elements, it is not it's not fully symmetrical. Its charge is not distributed equally in both molecules. So both molecules are polar molecules. And since they're both polar, they both have dipole-dipole. I'm just going to shorten it to dip-dip. And we will also have dispersion forces, like we said before. So dispersion. Now, what do we do with two molecules that have same kind of forces? We have to look at the molar mass. Who has higher molar mass? Well, Cl2CO has higher molar mass because it has chlorines, which are way bigger than hydrogen. Therefore, it has stronger intermolecular forces, and because of that, it will have a higher boiling point. So we will choose Cl2CO. This is Maya from Transformation Tutoring. I hope you found this lesson to be helpful, and I look forward to seeing you in more lessons.